I'm going to solve a few of the questions from the review worksheet, the extra review worksheet from Chapter 1, Honors Physics. Let's start with number 5. So what we want to solve for in number 5 is side B. Since side B is the side adjacent, since 350 is the hypotenuse, we're going to use cosine. The cosine of the angle, which is 17 degrees, is the adjacent B divided by 350. And so simply at that point, all we have to do is multiply both sides by 350. Side B becomes 340. And now, for number 6, we want to solve for side A. Then you have a choice. You could use tangent, you could use sine. It would be best to use sine because we're using something we haven't solved for. Let's use the sine of the same 17 degrees equals the side opposite, which is A, over the hypotenuse, 350. Multiply both sides by 350, and A becomes 100, with the 0 being significant. Let's look at number 9. Number 9 is not a right triangle, so it either has to be the law of sines or the law of cosines. Since we don't know two sides and the included angle, we are going to be using the law of sines. Now, the law of sines is some side divided by its opposite, with the sine of its opposite angle, equals any other side divided by the sine of its opposite angle. However, there's a little bit of a problem because 11.4 is opposite to an unknown side. This side right here happens to be 63 degrees. Now we know that because all three angles of a triangle add up to 180, and so that's how we can find the 63 degrees. Now we can use the law of sines. 11.4 divided by the sine of 63 degrees is equal to x over the sine of 49 degrees. Multiply both sides by the sine of 49 degrees, and x equals about 12.6. Let's look at number 11. Number 11 starts as d equals 1/2 the quantity v1 plus v2 times t, which will be one of the formulas we'll discover when we study kinematics. In this case, we know that d is equal to 73 meters. V2 equals 25 meters per second. And T equals 1.5 seconds. Two ways to solve it. One way would be to plug everything in right now. Another way to solve it, very reasonable way, even preferable in most circumstances, is let's solve for V1 using variables first. For instance, multiply both sides by 2 to start with. If you multiply this side by 2 and this side by 2, you get 2d equals, notice those cancel, parenthesis v1 plus v2 times t. Why not get rid of the t at this point by dividing both sides by t? Then you have 2d divided by t equals simply v1 plus v2. Notice the parenthesis is not necessary. And the last step simply will be to subtract v2 from both sides. Then we have 2d over t minus v2. At this point, we can substitute all of the variables, the numbers for variables, and we could take 2 times the displacement, which is 73 meters, divided by the time, which is 1.5 seconds. Subtract from that the V2, which is 25 meters per second. And we get V1 of 72 meters per second.